Okay, good afternoon everybody. Mr. Hudson here. Just going to go ahead and give you some notes over section 7.3, which deals with triangle similarity. You're going to see some similarities between this section and the sections that we did a while ago that dealt with congruent triangles. Now we're going to be talking about similar triangles. Now we've been talking about similar triangles, and what that means, just the fact that two triangles are proportional. But if you recall, with the congruency of triangles, we dealt with the side, 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 and the side, angle, side, and angles, and so on, all those. There are going to be some that are similar to those, and there are going to be others that may be a little bit different. And this first one that's on here is the angle-angle similarity, which simply states if you've got two triangles here, and you know that there are two pairs of angles which are congruent, then you can go ahead and conclude those two triangles are similar. And don't forget that this little symbol right here is the symbol for similar. If you need to at any point here, just pause this, and that'll give kids a chance to get caught up with writing. So if we look at these examples here, this says explain why the triangles are similar and write a similarity statement. Then if we look at this, well, we know that these two angles are congruent because of the VAT, the vertical angle theorem. So we can say that angle BCA is congruent to angle DCE. That's a C and that's a D, because of the vertical angle theorem. Also, we know that angle A is going to be congruent to angle D because of the right angle theorem. They're both right angles. Therefore, by what we just used there, that would be by angle-angle. We know the two pairs of angles are congruent. So what we could say is that triangle BCA is similar to triangle ECD. And notice how I'm matching those up like what we talked about in the last section. Here I'm just going to talk about this, explain why the triangles are similar, write a similarity statement. Well, in this particular case, we know that this angle is 43 degrees, which means this angle must be 47 degrees, because the 3 must add up to 180. If this is 47 degrees, this must be 43 degrees. So, if you notice, we do have two pairs of angles that are congruent, so that is using the angle-angle, and let me use this similarity statement. We could say that triangle ABC is similar to, now we have to match up the angles there, so it's similar to triangle DEF. That would be our similarity statement there. There are two others, and these actually look familiar. We have a side, side, side similarity, and something I want to point out here is with the congruence side, 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 that would have said three pairs of sides are congruent. Well, here we're talking about proportional. So we would say that three sides are proportional to each other. Down here is the side, angle, side. So again, when we talk about the sides there, we'd say that the two sides are proportional to each other. And then the angle that's included between those, so here are your sides and then the angle in between them, if those are congruent, then that would be the side, angle, side similarity. Again, if you need to, pause this so you can get caught up with your notes. So here we are to verify that these triangles are similar. Well, if we kind of match up some sides there, it looks like we have a 2 to 3 ratio. All right, if we're to go from PQR to STU, that means that side PQ, which has a measure of 3, is to ST, which has a side of 4.5, as QR, which is 3, is to TU, which is 4.5, as PR, and I'm just going to match up all these sides, 2, is to SU, which is 3. And if you simplify these two fractions over here, they actually simplify out to 2/3. Okay, so that's what allows us to believe, all right, these actually simplify to 2/3. All of those simplify to 2/3. Therefore, that is the side, side, side similarity. Whereas over here, if you take a look at this, DE, which has a measure of 2, is to HJ, which has a measure of 1, as DF, I'm going to take a side that I know, 5.8 is to HK, which is 2.9. And 5.8 over 2.9 is also 2. We have the angle in between them that are congruent, therefore that finds the side angle side similarity. Here we're to verify that these two triangles are congruent. Well, again, if you notice here, we've got the vertical angle theorem. Okay, if I have a ratio of 12 over 16, that simplifies to 3/4. I have a ratio of 15:20, that also simplifies to 3/4. Since these two angles are congruent by the vertical angle theorem, then that will be the side angle side similarity theorem. Okay, so as we move on here, we are to explain why triangle ABE is similar to triangle ACD. Well, let's take a look at this. We have a ratio, if we look at the sides here, this side AB is 9, and here the side AC would be 12. That's 9 plus 3, those two together would be 12, which is 3/4. Let's see what else we have here. We know that these are right angles, so those two angles are congruent, and actually they share this same angle. So I mentioned about this, but really I didn't need that ratio, because by the angle-angle theorem I can say these two triangles are similar. Again, they share this angle, so there's one pair of angle, and then these two are congruent, so there's another pair, there's the angle-angle. Then we're to find CD. So what I can do is I can write a ratio of 9 is to 12, so I'm going with the smaller triangle to the bigger triangle, as 5 is to x. Now as I cross multiply, I get 9x equals 60, so x would be 60 over 9, which would be 20 over 3, if you simplify that down. Okay? Here we're to say why triangle RSV is congruent to RTU, and basically for the same reason. If you notice here, these two angles are congruent and they share angle R, so that would be by angle-angle. Now we're to find RT. So I'm going to label that with an X here. I can say that 8 is the 12, I'm going to the ratio of the smaller triangle to the bigger triangle, as 10 is to the whole side there, which is x. Across multiplying, I have 8x equals 120. If I divide by 8, I get 15. Now 15 is what x represents, which is RT. Therefore, RT is 15. Alright. I paused because I know that you were just moaning and groaning. Well, yes, we have proofs. So I'll give you a chance to set that up there. We're going to prove that these two triangles, and this triangle UVT, is similar to RST. What we know, and what we're given up here, is that 3UT is equal to 5RT. Okay? Down, I'm going to find the other given information, which is this third step, so I'm going to go ahead and fill in the given information here. Now, if I take this equation and actually divide both sides by 3, that gives me 5/3 here. At the same time, if I divide through by RT, that gives me UT over RT. So to get from this statement to this one, division was used. Divide both sides. Okay? Likewise, division is used here. And notice that as a result of that division, we have each of those sides being congruent to 5/3. Okay, so these are proportional, we could say. UT is to RT as VT is to ST. We know that RTS, this angle, is congruent to this angle. Why is that? Why? Very good. Vertical angle theorem. And what we've just proven, we said something about these two sides, and the angle in between, so that would be the side angle side for similarity. We can just say side angle side. Okay? Looking at this proof, it says M is the midpoint of JK. Just kidding, M is the midpoint of JK. Okay? This is all our given information. N is the midpoint of KL. I'm going to mark some things down here, and we'll probably state those later. And P is the midpoint of JL. Okay? The measure of MP is equal to half of KL. Now, you would think that that would be definitional midpoint. That actually is not. If you look at MP and then KL, if you remember, that's what's called a mid-segment. This is the mid-segment theorem. And what the mid-segment theorem states is the mid-segment is half of this opposite side. Okay? So if I actually take and divide each of those here, I can divide by KL. I can divide here by JL, and that gives me all those ratios that are in step 3. Divide here by here by KJ. That gives me all of these. This was division. And since all 3 of those are equal to the same ratio, then that is the side, side, side similarity theorem. Those proofs were fun. Okay? Now, I tell you what, I'm going to just go ahead and let you take... No, I'll go ahead and do this. Sorry. If we know that AC is parallel to FG, ABC, the big triangle, is similar to FBG, then we're to find BA to the nearest 10. So we're going to find this side right here. Well, how I can do that is I can take a ratio of 6.5 over 24, set that equal to, that was a smaller triangle, to the bigger triangle. Now, we don't know the measure of this smaller triangle, so it's a little tricky. I'm going to call this measure right here x. So I'll say 6.5 is to 24 as x is to, and the measure of this side will be 17 plus x. So when I cross multiply, I'm going to take 6.5 times 17 plus x and set that equal to the other cross product, which would be 24x. Okay, I will let you go ahead and solve that. Solve for x, and that will find what b, and then you need to add that value for x to 17 here. So your answer is going to be 17 plus whatever that x value turned out to be. I'll be honest, I don't have a calculator with me, so I don't feel like doing that in my head right now. Sorry. All right. And here you can pause this real quick. Just talks about the properties of similarity. You'll see that they are very similar to something you've done before. Okay. Here's your assignment. Enjoy.